Hello all guys, I'm back with a new interesting video, and today our topic is chemistry. Recently have done chemistry, which is just a trick to write SPDF electronic configuration of any element. Yes, I think you have all learned how to write SPDF configuration easily, and did you practice some elements with that trick? If you practiced, just post it in the comment section. So today's topic is chemistry, and today we are learning about quantum numbers. Yes, the quantum numbers. In maths we have infinite numbers, but in chemistry we have numbers which are 4, and those 4 numbers are called quantum numbers. What is meant by quantum first? Quantum is nothing but eligibility. Okay, so right here, quantum or quantization. Okay, quantum is a verb form of quantization, which means eligibility. Okay, for example, let's take money. Okay, there is a 50 rupee note or 20 rupee note or 10 rupee note. Yes, or 500 rupee note, 200 rupee note. Only some notes, only some numbers of notes are there, but there is no note for 25 rupees. Yes, and there is also note for 100 rupees also. And again there is no note for 150 rupees. There is no note for 250 rupees. Yes, so only some amount there are notes. So only some numbers are eligible to be in the form of money. For example, 20, it is eligible to be in the money form. For example, a number called 250, is it eligible to be in the form of these notes? No, it is eligible only the sum of notes. Okay, now there is no sum is not related to quantization. Only sum. Say for example, 500 is there. Yeah, it is eligible for the money. Yes, it is eligible to be in the form of money note. Or let's take 10. Okay, there is a 10 rupee note, so it is eligible to be in the form of note. For example, let's take 150. No, it's not eligible. So only some amount. Like that, quantization is nothing but only some particular thing is eligible to particular thing. Okay. So I think you got the meaning of quantization. So let's go to quantum numbers. Okay, let's go to the topic of quantum numbers. Actually, there are 4 quantum numbers. Okay, there are 4 quantum numbers. Okay, what are they? They are, first one is principal quantum number. Okay, principal quantum number, and second one is azimuthal quantum number, and next is magnetic quantum number, and next is spin quantum number. Okay, so there are like this, there are 4 quantum numbers. Okay, and principal quantum number is denoted with N. Okay, and azimuthal quantum number is denoted with L, and magnetic quantum number is denoted with ML, and spin quantum number is denoted with MS. Okay, like this we have 4 quantum numbers in chemistry. Okay, they are principal quantum number, azimuthal quantum number, magnetic quantum number, and spin quantum number. Okay, first let's talk about principal quantum number. Okay. Okay. What is principal quantum number? Principal quantum number. What is meant by this? What is the help of this? What is the use of this? Okay. plays a main role. Okay, this plays a main role among all 4 quantum numbers. Okay, see, principal quantum number is the quantum number which describes about orbitals. Okay, which describes about orbitals, and here comes the new word orbital. Yes, what is meant by orbital? You have heard about orbit. You know that different planets have their orbit. Yes, but here what is orbital? The place. Okay, the 3-dimensional space. Okay, let's take 3D space. A 3-dimensional space. Okay, dimensional. A 3-dimensional space around the nucleus. Okay, around the nucleus, where the electron finding, where the electron existence. Okay, let's take existence. Where the electron existence is maximum. For example, let's take a nucleus with positive charge. Okay, there is an x orbital. Okay, there is a y orbital, and there is a z orbital, 2 z orbitals. In which orbital the electron might be? In which orbital the electron might be? We don't know in which orbital it is there. In these 4 orbitals, we don't know where the electron is there. So, among this space, electron will be there. We don't know where it is, but in this one it is there. So, this is the whole space where the electron existence is maximum. Okay? Did you understand? I repeat it again. 3-dimensional space orbital is a 3-dimensional space around the nucleus where the electron existence is maximum. Okay? I think you have understood this. And the quite opposite of orbital is node. N-O-D-E, node. What is meant by node? A 3-dimensional space around the nucleus where the electron existence is 0. The electron can't be found. How must you search in the place of node? You can't find any electron. So, the place where the electron existence is minimum or 0 is called a node. Okay? I think you are clear about it. Okay? So, I am wrapping this now. Let's talk about principal quantum number. I think you have understood what is the orbital, yes? Okay. And again there are 4 types of orbitals again, okay? We'll discuss about orbitals in a detailed way in the next upcoming chemistry episode, okay? Okay. So describes the orbitals. So I have just taught what is the orbital. So the quantum number which describes about this orbital is principal quantum number, which is denoted by n. Okay. So n, if n is, there are again 3 shells. You know there are shells around the nucleus. Yes, you know this one. I'll tell you what is the shells. I'll tell you clearly. Okay. And there are different shells around the nucleus. Yes or no? So these shells, there are infinite shells more. How many shells it might be? There are infinite shells more. Yes? Yes? So these shells are represented by n, which is principal quantum number. Yes? Because principal quantum number describes about orbitals. These orbitals are nothing but shells. Okay? So principal quantum number is nothing but shell. Is denoted by shell. Okay? So if this is n equals to 1, it is first shell. Okay? If this is n is equals to 2, which is second shell. Sorry, I wrote just reverse. This is n is equals to 1, which is first shell. This is n is equals to 2, which is second shell. This is n is equals to 3, which is fourth shell. Third shell. And this is n is equals to 4, which is fourth shell. Like that, if n is equals to infinite, it is infinite got it? Okay. If n is equals to 1, okay, what the shell is named as K shell. Okay. If n is equals to 1, see this one, it is K shell. If n is equals to 2, okay, if n is equals to 2, it is L shell. Okay, L shell, which is, this is L shell. If n is equals to 3, it is M shell. This is M shell. If n is equals to 4, it is N shell. So this is N shell. Okay, I think you are very much clear about it. Yes, I think you are very much clear about this. Okay, so let's go to the next quantum number, which is azimuthal quantum number. Okay, so principal quantum number totally describes about orbitals. So I think you have got it. Okay. Yeah. So let's go to the second quantum number, which is azimuthal quantum number. Which is denoted by L. Okay. If n is equals to 1, then the value of L will be 0. Okay. What is azimuthal quantum number? It describes about orientation of orbitals or shape of orbitals, okay, etc. About orbitals. It gives a complete information about orbitals. What is the principal quantum number? It describes the position, the electron existence, the electron foundation. So it describes about orbitals. But the azimuthal quantum number describes, means it tells the shape, size, or orientation, okay, or the geometry, which is octahedral, tetrahedral, etc. So I think you have understood the difference between principal quantum number and azimuthal quantum number. Okay, so azimuthal quantum number is nothing but it describes about the shape, size, orientation, etc. about orbitals. Okay, so okay, if n is equals to 1, the value of L is equals to 0. If n is equals to 2, the value of L will be 1. If n is equals to 3, the value of L will be 2. If n is equals to 4, which is N shell, the value of L will be 3. Okay, I think you have clearly understood this. Yes. So these are the orbitals, values of L, azimuthal quantum number. So okay, so this is about azimuthal quantum number. I think so you have clearly understood about this. Yes? Okay. So let's go to next quantum number, which is very important and the key role. It plays a key role among all 4 quantum numbers. Okay? If you remember principal quantum number, it is not that hard. But if you understand this, which is magnetic quantum number, this really plays a key role among all 4 quantum numbers. Okay, magnetic quantum number, it is denoted by ML. Okay, so what is magnetic quantum number? What is it? It describes about subshells. Okay, for example, if n is equals to 1, it is S subshell. Okay, I think that I thought you there are shells around this. Yes, so if n is equals to 1, it is S subshell. Here, okay, it is S subshell. It contains only one subshell. If n is equals to 2, it contains S and P subshells. S and P 4. It contains S, P, D, F subshells. Okay guys, if n is equals to 1, it contains S subshell. If n is equals to 2, which is second shell, which is L shell, it contains S and P subshells. If n is equals to 3, which is M shell, it contains S, P, D subshells. If n is equals to 4, which is N shell, it contains S, P, D, F subshells. And this SPDF, we use it in the electronic configuration, SPDF electronic configuration. So this is what the topic I explained in my previous chemistry video. And now I will write the full forms of S, P, D and F. So what is the full? S is nothing but sharp. Okay. S is nothing but sharp. P is nothing but principal. D is nothing but diffused. And F is fundamental. So instead of calling sharp subshell, principal subshell, diffused subshell, fundamental subshell, they just given their short forms, which are S subshell, P subshell, D subshell and F subshell. So okay. So in n is equals to 1, there is S subshell, which is 1 S subshell. This is denoted by 1s, and these subshells are denoted by 2s, 2p. Why? Because the n is equals to 2, so the coefficient of S and P subshells will be 2. So 2s, 2p subshells, and if n is equals to 3, it is 3s, 3p and 3d subshells. And if n is equals to 4, it is 4s, 4p, 4d and 4f subshells. Okay, there is one subshell, there are two subshells, there are three subshells and there are four subshells in each shell. Okay. So okay, I think you are very much clear about even magnetic quantum number. Yes. Okay. And there is not only this much, there is so much in magnetic quantum number more. So okay, if n is equals to 1, is it visible for you guys? Yeah. If n is equals to 1, then the value of L will be 0, and then the value of ML will be 0. Okay. And if n is equals to 2, which is L is equals to 1, the ML value will be minus 1, 2 plus 1. And if n is equals to 3, the value of L will be 2, which is ML value will be minus 2, 2 plus 2. And if n is equals to 4, the value of L will be 3 and the value of ML will be minus 3, 2 plus 3. Yes. And this is S orbital. Yes. This is P, D and F. See, from 0 it is 0, minus 1 is minus 1, 1, 0 and 1. And its minus 2 means minus 2, minus 2, minus 1, 0, 1, 2. Yes. And for minus 3 to 3, minus 3, minus 2, minus 1 and 0, 1, 2 and 3. See, there are, see if it is 0. Yes. See here, 1, 2, 3, 4. Yes. So there are 4 d orbitals. Yes. So there So yes, there are 3 orbitals in P and there is one orbital which is 0 orbital. See, if the value is 0, it is 1 orbital, yes. So there is one orbital. One orbital which is S. There are 3 orbitals which is P and there are 4 orbitals. 1, 2, 3, 4. Yes, there are 4 orbitals. -1, -2, -1, 0, 1, 2. There are 5. Okay, there are 5 orbitals in D and there are 7 orbitals in F. Okay, so there is one S orbital and there are 3 P orbitals. There are 4 D orbitals. Sorry, 5 D orbitals and there are 7 F orbitals. So now I am gonna explain all the names of the orbitals. Okay. So see, there is one S orbital which is S. Okay. There are 3 P orbitals which are Px, Py and Pz. Okay. So there is Px orbital, Py orbital, Pz orbital. And there are 5 D orbital which is dx, dy, dz, dxy, dyz, dzx, dx square, y square and dz square. Okay, so 1, 2, 3, 4, 5. There are 5 d orbitals and there are 7 f orbitals which are fz cube, sorry, not xz, fz cube. Okay, fxz square, fyz square and fxyz and fx, fy and fz. 1, 2, 3, 4, 5, 6, 7. There are 7 f orbitals. Okay. So this is about magnetic quantum number. So there is a lot to explain magnetic quantum number. See, if n is equals to 1, see why only one orbital in S. See, it is 1. L is equals to 0 orbital. See, if 0 orbital, it is L equals to 0. If it is L equals to 0, it is N equals to 1, which is first subshell. So it has one S orbital. Did you got it? Yes. So okay, let's move on to the next one, which is spin quantum number, which is a second key role. Yes. And yeah, one more thing to explain in this. Yeah. Okay. So each orbital, one orbital can accommodate 2 electrons. Okay. Each orbital can accommodate 2 electrons. Yes. This it is an ability. It is an ability of an orbital to accommodate 2 electrons. Okay. So each orbital can accommodate 2 electrons. So S has only one orbital, so it can accommodate 2 electrons. Since P in n is equals to 2, which is P subshell, there are 3 orbitals, so it can accommodate 6 electrons. And in D, there are 5 orbitals, so it can accommodate 10 electrons. And in F, there are 7 orbitals, so it can accommodate 14 electrons. So why I am keeping minus C is the charge of electron is negative charge. Yes. Okay. So S orbital can accommodate only 2 electrons and D orbital can accommodate only 10 electrons. Sorry, 6 electrons. And P orbital can accommodate 6 electrons. D orbital can accommodate 10 electrons. And F orbital can accommodate 14 electrons. Are you clear about this concept, magnetic quantum number? So okay, let's move on to the next quantum number, which is spin quantum number. Okay, and the next quantum number is spin quantum number. Which is denoted as ms. Yes, spin quantum number is denoted as ms. So there are two types of spins of electrons. Two types of spin of electron. Okay, which is upward spin. Upward spin. The clockwise rotation. Okay, the clockwise rotation of an electron is clockwise rotation of electron is upward spin. Okay, and the upward spin of electron is denoted by plus 1 by 2. Okay, so the value of upward spin is plus 1 by 2. And next is downward spin. Downward spin is denoted like this. Okay, this is downward spin of electron. It is an anti-clockwise rotation of electron. Anti-clockwise rotation of electron. It is denoted as the value of the downward spin of electron is minus 1 by 2. Okay, so the value of downward anti-clockwise spin rotation of electron is minus 1 by 2. Okay, so I think we are clear about the quantum numbers, which is spin quantum number. Well, that's it for today, guys, and thanks for watching. I think this quantum numbers is really tough concept for you. Yes, yeah, this is really tough concept in chemistry. You have to understand it. Okay, so if you understand it, you can really enjoy quantum numbers like me. Yeah, I understood it. I explained it to you. I'm really enjoying quantum numbers. Okay, so this is what all about today. So if you like the concept quantum numbers, just like the video. And also, if you want more knowledgeable videos, subscribe my channel. And with a leave, signing off your logical brilliance.